Hi, so I wanted to give you a quick little rundown on solving quadratics and good techniques to use when you are solving them. So we're going to talk about the four different methods and when to use them appropriately. So first of all, why do we even need to bother? We need to solve quadratics to help us find the zeros. The zeros are the x-intercepts. They're often called the roots. They are the solutions of a quadratic function. When we start getting into polynomials and we're finding the zeros of polynomials, quadratic techniques help us find those last couple of roots much easier. Once we use synthetic division to find some of the first roots, we can get down to a quadratic, which then is usually pretty easy to factor or use one of our other techniques to solve. The last reason is because quadratics are literally everywhere, especially if you are talking about physics. There are a lot of physics applications where quadratics are used, and it's important for us to be able to solve them quickly and easily and know what method is best to use given the situation. So technique number one is called square rooting. This works best if there is no middle term, no bx term, and it's really easy. You just square root both sides to solve. Now, before you square root, remember you have to get the x squared by itself. So in this example here, I would first start by subtracting 7 from both sides. Then I would divide by 5. Now I have my x squared by itself, and I can square root, which means the square root of 16 is 4. Remember that it is both positive and negative 4. So my two solutions for this quadratic would be positive 4 and negative 4. Square rooting is really nice and easy, but it really only works if there is no dx term. The second technique is called factoring. I hope this sounds familiar to you. I'm sure you've been working on it for quite some time. But it's generally a pretty easy way to solve a quadratic. Hopefully you feel comfortable with factoring by this point. It works best when a is less than 5. Once you start getting an a that's bigger than 5, you have a lot of factors to try to work with, and it becomes more time consuming and tedious to figure out which ones actually work. Not to say that it can't be done, but it's going to be easier for you if a is less than 5. You find the factors of the first and the factors of the third term, and you figure out how to place them so that they add or subtract to make the second term. The first thing you have to remember is that with every quadratic, it has to be equal to 0 in order to solve. So this one, I would start by adding that 12 to the other side. So now my quadratic is equal to 0. Now I want to figure out what factors of 2 and what factors of 12 can be used to combine to make 11. So I know 11 is close to 12, and I'm thinking, oh, 1 and 12, except that I have that 2 there. So let's actually start with that because that might be easier. I'm going to start by breaking that apart into a 2x and an x. Now I need some factors of 12 that are going to get me to 11. And I'm thinking probably 4 and 3. 11 is an odd number, which means I have to have an odd factor to add to it. 6 and 2 is not an option. We already decided 1 and 12 won't work. So let's try 3 and 4. So if I put 3 here and 4 here, how do I know if I have 11? Well, I multiply these two, which is 3x. I multiply these two, which is 8x, and I can see very easily that 3x plus 8x is equal to 11x. Therefore, both of my terms are positive, and I have now factored. Now we're not done. Remember that the goal here is to solve for x. So we have to take each parenthesis and solve it for what value makes that equal to 0. Well, this one's pretty easy. I would subtract 3. I would divide by 2. So x is negative 3 halves. I would do the second parenthesis the same way, solve, and all I have to do is subtract 4, and I've got my x there. So in this case, x is equal to negative 3 halves and negative 4. Not too bad if you can factor out. Notice a was less than 5. 2 is pretty easy to factor, and then I can just break the 12 apart and figure out where those numbers need to be positioned. Method number 3 is called completing the square. This really works best when a is 1. If a is not 1, it becomes a lot more difficult. You have fractions. It gets ugly pretty quick. This is sort of a combination of factoring and square rooting, and this is where we have to make it into a perfect square so then we can factor and square root. So we're going to start by adding in some blanks so that I can figure out what is going to make this a perfect square. I'm going to take half of 8, which is 4, and 4 squared is 16. That's what goes in my blanks. Now I have x squared minus 8x plus 16, which if I factor that is equal to x minus 4 squared. X minus 4 times x minus 4 is x squared minus 8x plus 16. Now I'm going to go to the other side. I'm just going to combine 17 and 16, which is 33. From here, now I've got a square. I can square root both sides. So on the left, I'm left with x minus 4 equals, plus or minus square root of 33. 33 does not have an integer square root, so I'm just going to leave that in the radical. The last thing I want to do is add 4 to the other side to get x by itself. And I end up with 4 plus or minus the square root of 33. So it's a little bit more of a complicated answer. The reason we have to do this is because this wouldn't have factored. There's no factors of 17 that can add or subtract to be 8. So we have to use a different method. Completing the square worked out pretty nice here because a is 1. The last method, the one that always works for every single quadratic, is the quadratic formula. I'm sure you've learned this before. There's even a fun song that goes along with it. But the formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The reason this is technique number 4 and not technique number 1 is because it can be a little complicated to work with. Notice I have some big numbers here. A is 9, B is negative 14, and C is 18. Those are going to give me some pretty big numbers. When I put them into the quadratic formula, I need to be careful to watch my signs, and I need to make sure that I simplify the radical, which often happens. So this is the most complicated method. Yes, it works for any quadratic, but it takes the most time and it's the most complicated technique out there. So if you can factor, if you can complete the square, if you can square root, you definitely want to do that first. If you can't, quadratic formula is your guy. So we know that A is 9, we know that B is negative 14, and we know that C is 18. We're simply going to plug those into the formula in all the different places. So I'm going to take the opposite of B, which makes my 14 positive. Then I'm going to take B squared. Please remember, anytime you square a number, it's always positive. So negative 14 or positive 14 squared is always going to be a positive 196. And then I'm going to take 4 times A, which is 9, times C, which is 18. You can see clearly this is going to require a calculator. Can't do this math in our heads very easily. And then that's all going to be over 2 times A, which is 9. Now I start simplifying. I'm going to leave that 14 alone for right now, and I'm going to start working with what is in the radical. So I have the square root of, and then I'm going to take 14 squared, which is 196, minus, and then I'm going to multiply 4 times 9 times 18. And I'm going to get my answer, whatever that might be. It helps if you have a calculator. I don't have one handy right now, so I'm going to multiply this by hand. And I get 648. All over 2 times 9, which is 18. Now I want to simplify farther by combining those numbers in the radical. So 196 minus 648 is going to give me a negative number. And that is going to be, let's see, 2, 14 minus 9 is 5, and 4. Now remember, anytime I have a negative inside the radical, that means I have an I in my answer. So I am going to have an I there, but I should also see if 452 can be simplified. I'm going to make a quick factor tree here. I'm looking for factors of 452 that are in pairs. So I'm going to start, I'm guessing I can divide this by 4, which is 113. 4 is 2 and 2. 113 doesn't really break down, but I have a pair here of 2s. So that's going to come out front with I. And now I can see that I can divide all of these by 2. So I'm going to do that. And I get 7 plus or minus I square root of 113 all over 9. That is my final answer. That definitely took some work to get there. So as you can see, this is definitely the most complicated one. You have to be really careful about your signs. You have to make sure that you are entering your numbers correctly and multiplying your numbers correctly. And there's a lot of simplifying that has to be done. However, the quadratic formula works for any quadratic, so it's always an option. You just kind of want to rule the other ones out first. So hopefully this rings a bell. Hopefully you remember these from Algebra 2, and you can now solve any quadratic or even any polynomial that comes across your plate. Best of luck to you.